Right, I think another example's in order, so let's try another one. So, brand new page. So in this case, here's a part B. So the question is the same. The vectors are different, so the vectors for A and B. So in this example, the vector A is given by 2i minus j minus 2k, and the vector B is given by 3i plus j minus 5k. Okay, so remember the question being to find a dot b, so that's the first part of the problem, and we need to work out the cosine of the angle between a and b. So let's have a look. So firstly, a dot b. So a dot b, that is equal to, so the vector A, that is defined by 2i minus j minus 2k, and we're taking the dot product of that with B, which is 3i plus j minus 5k. So once again, when applying the dot product or the scalar product, so remember, multiply the coefficients of I, j and k and then add. So if I multiply the coefficients of I, we have 2 into 3 plus multiplying the j coefficients, we have minus 1 into 1 plus multiplying the k coefficients, minus 2 into minus 5. So 2 into 3, that is 6, minus 1 into 1, minus 1, minus 2 into minus 5, plus 10. Okay, so 6 minus 1 is 5, added with 10 is 15. So that is a dot b. Okay, so that is the answer to the first part, a dot b, but we also need the cosine of the angle between A and B. So remember, looking at the formula over here, A dot B is modulus of A times modulus of B times cos theta. So we need to work out the modulus of A as well as the modulus of B again. So let's have a look. So the modulus of A, first of all, that is the square root of, so let's have a look. Coefficient of A is 2, so I rather, coefficient of I is 2, so 2 squared, plus the coefficient of j in the vector A is minus 1, so minus 1 squared, plus the coefficient of k in the vector A, which is minus 2 squared. Okay, so if we simplify, 2 squared is 4, minus 1 squared plus 1, minus 2 squared plus 4, and 4 plus 1 plus 4 is 9, square root of 9, 3. Okay, so that is the modulus of A. Let's work out the modulus of B as well. So modulus of B, that is the square root of, so looking at the vector B here, coefficient of I is 3, so 3 squared, plus coefficient of j is plus 1, so plus 1 squared, plus the coefficient of k in B, which is minus 5, so minus 5 squared. Okay, so if we simplify that, 3 squared is 9, 1 squared 1, minus 5 squared 25, and simplifying further, 9 plus 1 is 10, and 10 plus the 25 will leave it as root 35. Okay, so that is the modulus of A, that's the modulus of B. We have A dot B also. Let's apply the formula. So let me use the rearranged version. So I've rearranged it in the last example. Cos theta is a dot b over the modulus of a modulus of b. So using cos theta, that is equal to a dot b, okay, divided by the modulus of a times the modulus of b. So when I substitute the results that we have in the previous stages, a dot b we had 15, okay, divided by modulus of a is 3, modulus of b root 35. Okay, so 3 cancels with the 15 5 times, okay, so I'm going to leave it as 5 over root 35, but I could just as well rationalise that, okay, also. So that completes this video. I hope you found this video helpful, and I hope to see you in the next video. Thank you.